KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hello students, last class we discussed up to exercise 6.2 question number 6. Okay. Now in continuation to last class, we are discussing exercise 6.2 up to question number 9 completed. Question number 10, prove that the logarithmic function is strictly increasing on 0 to infinity. Okay, log x function, domain is what? 0 to infinity. Okay, so we have to prove that logarithmic function is strictly increasing on 0 to infinity. Okay, now as f of x equal to log x, now what is derivative of log x? F dash of x equal to log x derivative is 1 by x. Okay, f dash of x is 1 by x. Now as x belongs to 0 to infinity, as x positive, 1 by x is also positive only, no? Okay, as x positive, 1 by x is also positive. So f dash of x is greater than 0. As f dash of x is greater than 0, f of x is strictly increasing in the interval 0 to infinity. F of x is strictly increasing in the interval 0 to infinity. Now we have to prove that logarithmic function is strictly increasing in 0 to infinity. F of x is log x, derivative f dash of x equal to 1 by x. Okay, as x positive, x belongs to 0 to infinity, as x positive, 1 by x is also positive. As f dash of x is greater than 0, f of x is strictly increasing in 0 to infinity. Okay, next question. Question number 11, prove that the function f given by f of x equal to x square minus x plus 1 is neither increasing nor decreasing in the interval minus 1 to 1. F of x equal to x square minus x plus 1 is neither increasing nor decreasing in the interval minus 1 to 1. Okay, what is f of x? Given function f of x is x square minus x plus 1. So f dash of x equal to x square derivative 2x minus x derivative 1, constant derivative 0. So f dash of x is equal to what? 2x minus 1. Okay, so f dash of x equal to 2x minus 1. On putting f dash of x equal to 0, what we get? 2x minus 1 is equal to 0, x is equal to 1 by 2, x is equal to 1 by 2. Okay, now in the interval minus 1 to 1 we are verifying, in the interval minus 1 to 1. Okay, so in the interval minus 1 to 1 we have 1 by 2. So minus 1 to 1 is divided in minus 1 to 1 by 2 and 1 by 2 to 1. Okay, so minus 1 to 1 is divided in interval minus 1 to 1 by 2 and 1 by 2 to 1. Okay, now minus 1 to 1 by 2, minus 1 to 1 by 2, now minus 1 to 1 by 2. Now what is f dash of x? We have f dash of x is 2x minus 1, no? Okay, 2x minus 1. Okay, minus 1 to 1 by 2, easy number is 0. Minus 1 to 1 by 2, easy number is 0. So 0 if you put, f dash of 0 is what? F dash of 0 is minus 1, which is negative. So minus 1 to 1 by 2, f dash of x is negative. As f dash of x is negative, f of x is decreasing in the interval minus 1 to 1 by 2. Minus 1 to 1 by 2. Minus 1 to 1 by 2, f dash of x is decreasing function. Okay, minus 1 to 1 by 2, f dash minus 1 to 1 by 2, f dash of x is negative, f of x is decreasing function. Okay, next in the interval 1 by 2 to 1, okay, in the interval 1 by 2 to 1, okay, 1 by 2 to 1, in between 1 by 2 to 1, I'll consider 3 by 4, okay, 3 by 4, okay. Now if you write 3 by 4 here in place of x, 3 by 4, f dash of 3 by 4 is what? 2 into 3 by 4 minus 1, 2 into 3 by 4, 2 to cancel, 3 by 2 minus 1 is 1 by 2, which is positive, okay. So in the interval 1 by 2 to 1, f dash of x is positive. As f dash of x is positive, f of x is strictly increasing function. So in the interval minus 1 to 1 by 2, f of x is decreasing function, and in the interval 1 by 2 to 1, f of x is increasing function. So in the interval minus 1 to 1, at some part it is a increasing function, at some part it is a decreasing function. So in the interval minus 1 to 1, f of x is neither increasing nor decreasing function, okay. Now we have to check whether, we have to prove the function f of x equal to x square minus x plus 1 is neither increasing nor decreasing in the interval minus 1 to 1, okay. So minus 1 to 1 by 2, f of x is decreasing function, 1 by 2 to 1 is f of x is increasing function. But minus 1 to 1 if you consider, in some part, some portion it is increasing, some portion it is decreasing. So f of x is neither increasing nor decreasing in the interval minus 1 to plus 1, okay. Next question. Next question number 13. On which of the following intervals is the function f given by f of x equal to x power 100 plus sin x minus 1 is strictly decreasing, okay. F of x equal to x power 100 plus sin x minus 1 is strictly decreasing. Intervals are 0 to 1, pi by 2 to pi, 0 to pi by 2, and none of these. What is given function? Given function is x power 100 plus sin x minus 1. Now f dash of x is what? X power 100 derivative is 100 into x power 99 plus sin x derivative is cos x. Sin x derivative is cos x, okay. Now in the interval 0 to 1, in the interval 0 to 1, in the interval 0 to 1, okay, before going to interval 0 to 1, first of all option C I will check, option C is 0 to pi by 2, option C is 0 to pi by 2. In the interval 0 to pi by 2, first quadrant cos x positive, all trigonometric ratios are positive, so cos x positive, so this is positive, okay, cos x positive. Now 0 to pi by 2, pi value is approximately 3.14, approximately 3.14. So 3.14 by 2, 3.14 by 2 is 1.5 something, okay, 1.5 something, okay. So 0 to 1.5 something, x positive, 0 to 1.34, 1.5 something, that is x positive. So x power 99 positive, 100 into x power 99 is also positive, okay. So x power 100 into x power 99 positive, cos x positive, their sum is also positive, their sum is also positive. So f dash of x is positive in the interval 0 to pi by 2, okay. So f dash of x is positive means f is strictly increasing in the interval 0 to pi by 2. So option C is not correct answer. We have to give the interval in these options where the function is strictly decreasing, okay. Whereas option C 0 to pi by 2, cos x positive, 100 into x power 99, this is positive, their sum is positive. So f dash of x is greater than 0 in 0 to pi by 2. As f dash of x is positive, f is strictly increasing in the interval 0 to pi by 2. So in interval C, in option C, interval 0 to pi by 2, f of x is increasing, okay. Now if you observe option C 0 to pi by 2, 0 to pi by 2, option A is 0 to 1. Actually 0 to 1 is a subset of 0 to pi by 2, because pi by 2 value is greater than 1, pi value is 3.14, 3.14 by 2 is greater than 1.5. So this is 0 to 1.5, approximately more than 1.5, this is 0 to 1. So obviously this is subset of this set. So increasing in this interval means obviously increasing in this interval also. So option A, if you verify, okay, in the interval 0 to 1, cos x positive, 100 into x power 99 positive, their sum is positive, so f dash of x is positive, so f is increasing function in the interval 0 to 1, okay. So f is increasing in 0 to 1, 0 to pi by 2. Now what about option B? Okay, now pi by 2 to pi, pi by 2 to pi means 1.5 something to 3.14 something. 100 into x power 99 is positive, okay, more than 1 also, more than 1 also, okay. Now cos x negative in the interval pi by 2 to pi, second quadrant cos x negative, but value is what? Value lies between -1 to 0. Cos x value lies between -1 to 0, but 100 into x power 99 is way more than 1. So obviously 100 into x power 99 is greater than cos x, okay. So their sum is also greater than 0 only. 100 into x power 99 plus cos x is greater than 0. So f dash of x is greater than 0 in the interval pi by 2 to pi also. So f is increasing in the interval pi by 2 to pi also. So f is increasing in 0 to 1 interval 0 to 1, interval pi by 2 to pi, interval 0 to pi by 2. So option is what? None of these. None of these. Okay. Next. The next question number 12. Which of the following functions are strictly decreasing on 0 to pi by 2? Which of the following functions are strictly decreasing on 0 to pi by 2? Okay. First question is cos x. The given function is cos x. Let f of x equal to cos x. Now f dash of x is what? Cos x derivative is minus sin x. Cos x derivative is minus sin x. Okay. In interval 0 to pi by 2, first quadrant. Okay, in first quadrant all 6 trigonometric ratios are positive, so sin x is also positive, but minus sin x is negative. Sin x positive, minus sin x is negative. So f dash of x is what? Less than 0. So as f dash of x is less than 0, f of x is strictly decreasing function on 0 to pi by 2. Okay, f of x is strictly decreasing function on 0 to pi by 2. Okay, now cos 0 is 1, cos pi by 2 is what? 0. Now as you move from 0 to pi by 2, 0 to pi by 2, cos x decreases from 1 to 0. Overall cos x is decreasing function. We'll write like this: f of x equal to cos x, f dash of x is minus sin x. Okay, in 0 to pi by 2, sin x is positive, minus sin x is negative. Okay, so f dash of x is less than 0, f of x is strictly decreasing in the interval 0 to pi by 2. Okay. Now second question, f of x equal to cos 2x. Cos 2x derivative. Okay, f of x equal to cos 2x. Now f dash of x is equal to what? Cos 2x derivative is sin minus sin 2x into 2. Cos 2x derivative minus sin 2x into 2. Okay, nothing but minus 2 sin 2x. Okay. Now as x belongs to 0 to pi by 2, 0 to pi by 2, 2x belongs to 0 to pi. X belongs to 0 to pi by 2. In the interval x belongs to 0 to pi by 2, 2x belongs to 0 to pi, means sin 2x either lies in first quadrant or in second quadrant. As 2x belongs to 0 to pi, sin 2x lies either in first quadrant or in second quadrant. Okay, either in first quadrant or second quadrant. In both the quadrants sin 2x, sin is positive, no? So sin 2x is positive in first and second quadrant. So sin 2x is positive, but sin 2x is multiplied by minus 2. Sin 2x is multiplied by minus 2, which gives a negative quantity. Okay, so f dash of x is less than 0. So f dash of x is less than 0 means f of x is strictly decreasing function. So f of x is strictly decreasing on 0 to pi by 2. That is what it is written here. F of x equal to cos 2x, its derivative f dash of x is equal to minus 2 sin 2x. So in the interval 0 to pi by 2, in interval 0 to pi by 2 means x belongs to 0 to pi by 2, 2x belongs to 0 to pi, sin 2x either in first quadrant or second quadrant. In both the quadrants sin 2x is positive. This is positive multiplied by minus 2, that is negative. So f dash of x is negative. So f of x is decreasing function in 0 to pi by 2. Okay. Now third part, that is f of x equal to cos 3x. f of x equal to cos 3x. Now cos 3x derivative minus sin 3x into 3. So nothing but f dash of x equal to minus 3 sin 3x. Minus 3 sin 3x. Okay. Now minus 3 sin 3x. Now x belongs to 0 to pi by 2. 3x belongs to 0 to 3 pi by 2. Okay. So I'll divide intervals like this. 0 to pi by 3. X belongs to 0 to pi by 3 and x belongs to pi by 3 to pi by 2. Okay. In the interval 0 to pi by 3, in the interval 0 to pi by 3, so as x belongs to 0 to pi by 3, 3x belongs to 0 to pi, no? 0 to pi. Now as 3x belongs to 0 to pi, sin 3x lies either in first quadrant or second quadrant, in both of which sin is positive. So sin 3x is positive, sin 3x is positive wherever x belongs to 0 to pi by 3. Okay. As x belongs to 0 to pi by 3, sin 3x lies either in first quadrant and second quadrant, which is positive. Positive sin 3x multiplied by minus 3. So positive into negative is negative. So f dash of x is less than 0. f dash of x is less than 0. So f of x is strictly decreasing when x belongs to 0 to pi by 3. Okay. f of x is strictly decreasing on the interval 0 to pi by 3. Okay. Now when x belongs to pi by 3 to pi by 2, when x belongs to pi by 3 to pi by 2, x belongs to pi by 3 to pi by 2, 3x belongs to what? 3x belongs to pi to 3 pi by 2. 3x belongs to pi to 3 pi by 2. Now pi to 3 pi by 2 is a third quadrant. In third quadrant sin is negative. Okay. So sin 3x will lie in third quadrant. In third quadrant sin 3x is, in third quadrant sin is negative. Okay. Sin is negative. So sin 3x negative. Negative multiplied by minus 3. Negative into negative is what? Positive. So f dash of x is greater than 0. So f dash of x is greater than 0 in the interval pi by 3 to pi by 2. Okay. So here in the interval pi by 3 to pi by 2, f of x is strictly increasing function. Okay. So f of x is equal to cos 3x. But this function in some portion it is strictly decreasing, some portion it is strictly increasing. Okay. 0 to pi by 3 it is a decreasing function, pi by 3 to pi by 2 it is increasing function. So 0 to pi by 2 f of x is equal to cos 3x is neither decreasing nor increasing function. So f of x is not strictly decreasing in the interval 0 to pi by 2. Okay. Now fourth part, tan x. Let f of x equal to tan x. Now tan x derivative is what? Secant square x. F dash of x is equal to secant square x. Okay. In first quadrant all 6 trigonometric ratios are positive. So for the interval x belongs to 0 to pi by 2, secant is positive, so secant square is also positive. So f dash of x equal to secant square x is greater than 0. So f dash of x greater than 0 means f of x is strictly increasing function. So f of x is strictly increasing means f of x is not strictly decreasing on the interval 0 to pi by 2. Okay. So D question, f of x is tan x, its derivative is f dash of x equal to secant square x. In 0 to pi by 2 all trigonometric ratios are positive, so secant square is also positive, so f dash of x is greater than 0. As f dash of x is greater than 0, f of x is increasing in the interval 0 to pi by 2, so f of x is not decreasing in the interval 0 to pi by 2. Okay. Next question number 14. Question number 14, find the least value of a such that the function f of x is equal to x square plus ax plus 1 is strictly increasing on interval 1 comma 2. You have to give least value of a such that f of x is strictly increasing on 1 to 2, interval 1 to 2. Now what is f of x? F of x is x square plus ax plus 1. Now first of all find f dash of x. F dash of x is equal to x square derivative 2x plus ax derivative a. 2x plus a. Okay, 2x plus a. Now in the interval 1 to 2, in the interval 1 to 2 means 1 less than x less than 2. Now 2x means multiply 2 throughout. So 2 less than 2x less than 4. 2 less than 2x less than 4. Add a throughout. So what will get? 2 plus a less than 2x plus a plus less than 4 plus a. Now 2x plus a lies between 2 plus a to 4 plus a. Okay. What is question? Find the least value of a such that function is strictly increasing. Strictly increasing, since f of x is strictly increasing, what should have? This has to be greater than 0. F dash of x has to be greater than 0, means 2x plus a has to be greater than 0, no? Okay, means 2 plus a has to be greater than 0. 2 plus a has to be greater than 0. 2 plus a has to be greater than 0. So 2 plus a greater than 0 means a greater than minus 2. So a greater than minus 2. So a greater than minus 2 is least value of a is equal to what? Minus 2. Least value of a is minus 2. Least value of a is minus 2. Okay. Next.